Okay, this is trigonometry. We're going to start with a short little review of triangles. This is a triangle, and how we name it is by the vertices. It could be triangle A, B, C, triangle C, B, A, and there's a few other ways to write it. As long as we have all three vertices, we're pretty good here. Okay, however, angles in triangles need to be named a certain way. The vertex of the angle must always be in the middle. Okay, or you can also name this angle A. Okay, here we have angle ABC, or we could call this angle B. Here we have angle ACB. Notice the vertex is in the middle, or we could also call this angle C. Okay, be careful. If you have another angle attached to this, you may not use this. You have to use all three letters. That way we know which angle you are talking about. Now let's look at the sides. This is side CB. What's the difference between a side and an angle? Notice the angle has an endpoint made up of an endpoint, that's the ray, and it goes on to infinity here. This segment has two endpoints. It has a beginning and it has an end. Another segment AC, or side AC, and side AB. Okay, take a moment to answer these questions. Use your own words. Okay, we're going from geometry to trigonometry. In geometry, when we have a right triangle, this is called the hypotenuse. It is opposite the right angle. In trigonometry, opposite the right angle is the hypotenuse. No change there. However, in geometry, we would call this a leg and this a leg, and we use the formula a squared plus b squared equals c squared, which we will need in trigonometry. However, over here, these are not called legs. This may be called opposite, and if this side of the triangle is opposite, then this side is adjacent. If this side over here is adjacent, then this one is opposite. But how do you know which one is which one? Let's look at all the parts. We're starting with the hypotenuse. Okay, the hypotenuse. First, we'll label or identify, shall we say, our right angle. It is already labeled for us, right angle, right there. Across from it, the one that has no red on it, is the hypotenuse, or the HYP. Okay, that's it for that. Okay, now the opposites. Again, the opposite is going to depend on which angle you are talking about. We have taken care of angle C, because that's the hypotenuse. We're done with angle C. Now let's look at angle A and angle B. We're going to start with angle A. Okay, angle A. The opposite of angle A is this side over here that has no part of angle A. And if this is the opposite, then this must be adjacent. Again, if we look at our definition, it says opposite is located on the other side, the end, or the corner of something, across from something. If we look at our angle, across this angle, all the way over here is the opposite. Okay? Next, look at, oh, here we go. One way we could think of this, and this came from one of your classmates, he thought of the angle eating up the opposite sides. So the angle is like the lip, and the opposite is the side that is going to get eaten. Just a little visual for you. Okay, adjacent. What if we wanted to start with adjacent instead of the opposite? Before we do anything else, just got to make sure that you notice this is your hypotenuse. If we don't label your hypotenuse, it can get confusing. Okay, so let's look at adjacent. It means not distant, nearby, having a common endpoint or border. We have two sides here. Let's look at those sides. I'm going to color them in. Okay, the ones I have to worry about is the pink one and the green side here. Again, I'm not going to worry about this one because it's a hypotenuse. We're done with that. They have to share a common endpoint or border. Okay, this is an endpoint for my angle because it's made up of two rays. A ray, remember, a ray has an endpoint and it goes off into infinity. Okay, so here is my endpoint for this one, my endpoint for this one. So it is A, this part here that is shared in with this segment. So this has to be adjacent. And if this is adjacent, what is this? Opposite. Okay? Let's look at another angle, which would be angle B. Okay, so in reference to angle B, label the sides as a triangle. Okay, first thing we gotta do is we gotta say this is the hypotenuse, and we're going to label our angle. So, hypotenuse. First off, we're done with this. We don't have to worry about this. For me, I find it easier to find the opposite because it's the side that is not part of the angle. So I call this the opposite. So for angle B, the opposite is side AC. And finally, if this is the opposite, then this must be adjacent. And again, if you look at this segment BC here, you'll notice that they have a common endpoint. Oh, that didn't quite land in the right spot. Okay, they share, the angle and this segment share this endpoint. So 3. Angle B is adjacent to side BC. I want you to notice something. Notice that the side and the angle have something in common when they are adjacent. When they are not adjacent, notice that B does not appear here. Okay, so let's try some problems. Okay, so here's our triangle. First thing we're going to do is find the hypotenuse. Okay, well, for that we need to label our triangle. Here's angle. The 90-degree angle is here. There's my 90-degree angle. So then this must be my hypotenuse because it's opposite of this one. Okay, so 1. For triangle X, Y, Z, the hypotenuse, the hypotenuse is segment ZX. Okay, now I got to decide which angle I'm going to start with. So I'm going to go ahead and start with angle X. You always got to know what angle you're talking about, because it'll change depending on the angle. Okay, so here we go. Now we're looking at angle Z. Angle Z, and just because I can, I'm going to go ahead and start, instead of looking at the opposite, I'm going to figure out which one is adjacent to angle Z. So adjacent to angle Z, well, again, this is the hypotenuse. Don't have to worry about this one. Adjacent, they have to share the same endpoint. So here is my vertex, which has the endpoint for my angle, and that must mean it would be this side here, ZY, must be adjacent. What do you notice here? Okay, and if this is adjacent, this must be opposite. Opposite. Okay? Okay, I think we have time for one more. Okay, I'm going to go through this fairly quickly. Here's my angle. A right angle. So this must be the hypotenuse. Okay, so that is my hypotenuse. For triangle DOG, the hypotenuse is segment DO. Let's look at the angles. Okay, so here we go. We're going to redo these triangles, and we'll look at angle D and angle O. So let's start with angle D. Okay, opposite. There's the one that's not colored. So opposite of angle D, opposite of angle, that is GO from here to here. So adjacent must be DG. Again, this is a hypotenuse, don't have to worry about it. Okay, opposite of angle O. Here's angle O. Opposite is DG. Adjacent must be the other one, which is GO. They have the same endpoint. Okay, I'd like you guys to try a couple of problems. Let's see. Here they are. And there's this one. Okay. So after you are done, you take your notes. Make sure you want to get credit. Write a summary of what you learned in the comment section, or you can email it to me. Sign it with your number, initials, and period. Do not write your name or any other personal information, okay? Do not. Okay? And turn in your notes when you get back to class. So again, you can leave it in the comment section or email me on this site. See you later, guys.